Okay, welcome back. So we are now on homework 4, which is 9.4, the derivative. And if you're watching this, I am in Ireland. So think of me in all the green grass and the hillside. As we work through this, let me go ahead and share my screen. As we work through this, when we're talking about a derivative, what we're talking about is the fact that we're going back to the equation of a line. So the equation of a line is y equals mx plus b. That's your slope-intercept form. The slope is your m. That's what the m represents. And the slope is all about the rise and the run. So it's the relationship, if you will, or the ratio between how far up and down something goes and how far right to left it goes. So for instance, if I have a point right here and I rise 1, so I go up 1 and I run 2, I have another point over here. Well, the exchange between the rise and the run, I rise 1 and I run 2, so I rise 1 and I run 2, that is my slope. That's how that relationship between the slope is. The larger the number, the steeper the slope. So if I change my color here, and let's say I have a point again right here at the origin, and I rise 3 and run 1, now you can see that my slope of my line is much steeper. So with this one, the slope is I rose 3 and I ran 1, which is a whole number 3. So the bigger the number, the steeper the slope. The smaller the number, the less steepness that slope has. Okay, so that is the relationship between what a slope is, the rise and the run. So when we're looking at the average rate of change, what we're looking at is just slope. That's all that means. So slope is just average rate of change. It's the how much it changes between the rise and the run. That's what we're looking at. So when we're looking for average, we're just looking for slope between 2 points. Okay, that's the slope that you're used to seeing, and that is what's called the secant line. So a secant line has 2 points. Okay, so it's 2 points. So we're just looking at how, what the relationship is between those 2 points. So one way to get that is, here's example 1. Let me get back to my pen here. When you have revenue generated by producing and selling widgets, anything that you're selling, the revenue is capital R of x times 75 minus 3x for the points between 0 and 20. So remember, this is your interval notation, right? It's between 0 and 20. So, and the brackets mean that it includes the 0 and the 20. So those are endpoints that are included. So it's saying, what is the change in revenue if the production changes from 9 to 12 widgets? So what we're doing is we're looking for, okay, I need 2 points, right? Just like this line here, I had a point here and a point here. Well, here I need 2 points. So remember, your ordered pairs are always in the order, the number and the dollar amount, right? The number and the revenue, if you will. So the first point, we know we have 9 widgets. So we're going to figure out, okay, well, what is our revenue when I plug in 9? So if I plug in 9, so we have our revenue at 9. So I have 9 times 75 minus 3 times 9. So the revenue, when I have 9 widgets, so 75 minus 27. So remember, order of operation, you do everything on the inside first. So 48 times 9. So my revenue is 432. So when I have 9 widgets, my revenue generated is 432. My other point is when I have 12 widgets. So now we're going to find the revenue at 12. So I have 12 times 75 minus 3 times 12. Okay, so all I'm doing is I'm taking out the x and I'm plugging in 12. That's all I'm doing. Okay, so 75 minus 3 times 12 is 36. So 75 minus 36. And that answer times 12, I get 468. Okay, so here's my 2 points. Here's my X and Y, here's my X and Y. So now I can go back to using my slope formula, because what I'm looking for is how is it changed between 9 and 12 widgets? Well, I'm going to do my Y minus Y over my X minus X. So 468 minus 432 is 36. 12 minus 9 is 3. So my average change in revenue is 12. So because we're talking about revenue, we can see, okay, the average revenue that I'm generating is $12, because this is what my slope is. It's the dollar amount divided by the number. So it's $12 per widget. That's what my revenue is, how my revenue is changing. Okay. So I already answered B. Sorry, I had to read it. Okay, so what is the change in revenue? So from 9 to 12, 9 we had $432. For 12 we had $468. The average rate of change is our slope formula. So Y minus Y over X minus X. I just did it above instead of below. So it's $12 per widget. Okay, so again, all we're doing is using slope. Now that is average rate of change. Okay, in calculus, we're looking for instantaneous rate of change. So instantaneous means now we're talking about a tangent line. So a tangent line, so if we had our graph, our tangent line, so we had a graph here, is what is the slope right at that point? So a tangent line, it only hits at one point, where the average rate of change, it's hitting at 2 points. So secant line is 2 points, tangent line is 1 point. And when we're looking at 1 point, we're looking at that instant. What is the slope? What is the average, or what's the rate of change at that particular point? Okay, which would be different if we had a point here, right? Our slope would be very different. So you can see with instantaneous rate of change, now we can look at a very specific point. All right, now, if you remember at the very beginning, we talked about difference quotient. Okay, so difference quotient right here is just slope. That's all it is. That's all difference quotient is. Here's the difference though. Now we're looking at the instantaneous rate of change. So what this is the definition of a derivative. So remember when we talked about the difference quotient, we talked about here we have our X value, here we have our X plus H. Well, that H value is this distance, whatever we added to X to get from this point to this point. Well, now what we're saying is our H value is heading towards 0. That means it's getting smaller and smaller and smaller. So if you're looking at a graph, right, and we're looking at the secant line, so we're looking at, what's the slope between these 2 points, that's your secant line. Well, those 2 points are getting closer and closer and closer and closer and closer together. So this point is moving this way, this point is moving this way. So what happens is we get to a point where our H value is very, 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 very close to 0. Now it can't be 0 because remember, with a fraction, you cannot have 0 in the bottom. but you can have a number that's very, very, very close to zero, like 0.000001. Okay, that is okay to have in the denominator. You just can't have zero. So that's the big difference, is our h value, right? That distance is getting smaller and smaller and smaller, and it's approaching zero. It's getting so small that it's super close to zero, but it's not zero exactly. Okay, that's the definition of the derivative. So we can find the slope at any particular point on a function that's very specific. It's in one spot. It's a tangent line that's tangent, right? Tangent means next to. So tangent next to the line. Okay, so we're able to now, instead of finding average rate of change, now we're going to find instantaneous rate of change at a very specific point. Okay, now there's different ways to write derivative. These are our, let me highlight them. These are different ways that we can say derivative. Derivative is shown, this is our most common, the f prime. So you see a little tick mark. This is another one that's pretty common, y prime. This dy dx is another way. And these two we don't really use a whole lot, so I'm just going to X those out. But these are the three that you're going to see the most. And all it means is derivative. That's all it means is, okay, when I think of derivative, I think, all right, derivative is just slope at one particular point. That's all it is. So when you hear the term derivative or the instantaneous rate of change, all you have to think of is, oh, it's a slope at a very specific point. That's all it is. And so we find that slope by using the difference quotient. And then we take that zero, or that h, to zero. And then we can find a slope anywhere on our function. So let's just walk through the step-by-step method. Remember, there's a step-by-step method for finding difference quotient. So steps 1, 2, and 3, you already know how to do. We already did it. That was in the review. The only difference now is we're going to put the limit, remember, as it's approaching, with the difference quotient. Okay, so let me walk you through this. So just a real quick recap. It helps if I have a pen. Remember, x plus h squared is the same as x plus h times x plus h. So you're going to do the FOIL. And again, if you have this memorized, it just saves you this step. So x times x, that's your outside. I'm sorry, that's your first. X times h is your outside. H times x is your inside. And h times h is your last. So we have first, outer, inner, last. So remember FOIL. Okay, so when I put this all together, x plus h squared will always be x squared. I have 2 xh's plus h squared every time. So if you have that memorized, you don't have to take that step. You can just automatically start by plugging that in. Okay, so step 1, here we go. We're going to take out our x, and we're going to plug in x plus h. Every time I see an x, I'm going to plug in x plus h. Now it's just algebra. That's all it is. So x plus h squared is, I'm going to highlight this, x plus h squared is our x squared plus 2xh plus h squared. That never changes. That will always be the same. And then I'm going to distribute this 5 through. So negative 5 times x is negative 5x. Negative 5 times h is negative 5h plus 3. Notice the 3 is not part of the parentheses, so that's just separate. Now I'm going to distribute again and clean this up. 2 times x squared is 2x squared. 2 times 2xh is 4xh. 2 times h squared is 2h squared. And then I'm going to complete this. Just keep writing. So this is answer to number 1. Took out the x, plugged in x plus h. Okay, now I'm going to take this same exact answer. I'm just going to rewrite it. and I'm going to subtract off, that's what this part is. I'm going to subtract off the original function. Notice I put it in parentheses, super important. If I don't put it in parentheses, then all I'm doing is taking off the 2x squared, but I am taking off the entire thing. So what that means is that negative gets pushed through all three terms. So I end up with negative 2x squared plus 5x minus 3. So all that does is it just changes the sign. Okay, so I'm going to rewrite this first part. And now I can cancel. I have a positive 2x squared and a negative 2x squared. I have a negative 5x and a positive 5x. I have a positive 3 and a negative 3. If you notice, your answer for the second step will always be terms with an h in it. So I have 4xh plus 2h squared minus 5h. And that is all that's left. Okay, so that's for step 2. Step 3 says, take your answer to step 2 and divide by h. So I'm going to take my answer for step 2. And you can see this is just all algebra. That's all this is. From this point on, it's just distributing. It's, FOIL and then distributing. And now I'm adding like terms. I'm pushing that negative through and adding like terms. And now I'm going to factor an h out of the top. Okay, so I factored the h out. I have 4x plus 2h minus 5. And now I can cancel the h's. So step 3, I end up with 4x plus 2h minus 5. Okay, that's your step 3. This is your difference quotient. That's the slope. Well, step 4 is new. Now we're going to take the limit as h goes to 0 of our function. Okay, so if h goes to 0, what that means is I end up with 2 times 0. Remember that idea of just plugging in the value. Well, this cancels. This 2h cancels out. So my instantaneous rate of change, so my slope at any point on my graph is 4x minus 5. Okay, now remember Desmos. Let me go back and show you Desmos. Remember Desmos. Desmos is a great tool to have open. So we started with 2x squared minus 5x plus 3. Right? Yes. Okay, so here's our graph, right? Here's the graph. Well, remember our instantaneous rate of change says 4x plus 3, right? Yes, 4x plus 3. Let me double check. Oh, I'm sorry. Not plus 3. Hang on. So our our derivative, right, was 4x minus 5, excuse me. So this is our definition of the derivative. So remember, derivative means slope. So what this means is I can plug any value for x in here and I can tell you what the slope is. All right, so let's try x is 2. So I'm looking at the slope right at this point. Okay, I want to know what's the slope of that green line. All right, well, if I plug in 2, so the derivative at 2, so remember the tick mark, that means derivative. The derivative at 2 is 4 times 2 minus 5. Now, when you look at this green line, you know that it should be a positive slope. right? Because my line is going uphill, it's increasing. So this number needs to be a positive. So 4 times 2 is 8, 8 minus 5 is 3. So the slope right at x is 2 is a positive 3, okay? It's an increasing slope. So what that means is at that point, my rate of change is increasing by 3. So let's say this is, a business graph. All right. What that means is if this is my revenue function, right? The original was my revenue function. This is the rate of my revenue is increasing at $3 per item when I have 2 items. Right. So remember, X is always the number of items. The Y value is always going to be the value, the dollar amount. All right. Now that's great for that one. But what if I wanted to know what's my instantaneous rate of change here? Well, when I put a line here, it's completely different. That purple line is going downhill, which means I should have a negative slope. So let's try it. So my derivative at -1, let's see if it works. 4 times -1 minus 5. So -4 minus 5 is a -9. Well, this slope is very steep compared to this one. Right? The green one isn't quite as steep as the purple one. So the purple one is a negative slope. So if this was in business, I could say when I had, negative, and this makes logical sense, if I have negative number of products, I'm going to have negative revenue. Makes sense, right? So the power of the definition of the derivative is very, very important to a business setting, because you can look at your graphs and you can look at what's going on with your business, and you can pinpoint at very specific places what's happening with your business. And then you can start asking questions like, okay, why am I increasing when I have 2 products? What's going on right here? Let me change my color. What's going on like right here at about 1 1/4, right? What would the slope be here at 1 1/4? Well, I can figure that out, and I'm guessing it's 1 1/4. If I put the cursor on here, it'll tell me exactly what it is. Yeah, I'm pretty close, about 1.23. Okay, so at 1 1/4, let's see what happens. At 1.25 minus 5. So again, I'm looking for what's my slope doing. So 4 times 1.25 minus 5, well, look at there. It's a 0. So look, a 0 slope. So this goes back to a review question. A 0 slope is a horizontal line. So what happened? I was decreasing my revenue here. Something happened right here and it switched, and now I'm increasing my revenue. So the definition of derivative is very powerful. We can do a lot with it. So let's go back to the difference quotient, right? Difference quotient, we walk through the process. Remember, it's a 3-step process, and then the only thing new is determining the limit. Oops, I gotta erase all this on my drawings. Okay. All right, so let's try this again. So now, this is now saying, okay, determine the instantaneous rate of change, same function, right? We already know what the instantaneous rate of change is. Our derivative, so remember, this is our notation, the little tick mark is derivative, is 4x minus 5. And they want to know, okay, what's going on right at x is 1? So the derivative at 1 is 4 times 1 minus 5. So 4 minus 5 is -1. Well, when we look back at our graph, this is our graph, at 1, it's right here. Sorry. I meant this. This is what I want. At 1, I have a negative slope. Sorry, I have a negative slope. Okay, at x is 1. So this the instantaneous rate of change. So remember, these all mean the same thing. Instantaneous rate of change, definition of a derivative, is the slope at a very specific point. Okay. All right. So let's go back to our OneNote. Too many buttons to push. Oops. Okay, so here we go. So we found the instantaneous rate of change, or the derivative, the slope, right at x is 1. All right, so then it says, now this one is a little bit different because now it's asking for the slope of the tangent line. So remember, the tangent line means it hits at one point, right? So if we have a graph, okay, we have a graph, and let's just say, it looks something like that. We don't know exactly what it looks like, but that's what it looks like, kind of. I'll put it on Desmos in a minute. So this x squared plus x at x equals 1. So when it asks for slope of a tangent line, what it's saying is, okay, if this is x is 1 right here, right, there's x is 1, we want to know what's the slope of that line, that tangent line right there. And again, tangent means it just hits at one place. So all we're looking for is the definition of the derivative, the instantaneous rate of change. That's what we're looking for. So when you see slope of the tangent line, you need to make sure that that means the definition of the derivative. Because it's not asking for the equation of the tangent line, it's asking just for the slope. So remember, derivative and slope is the same thing, okay? The derivative is the slope at one particular point, which is a tangent line, okay? So here we go. So you're going to use the definition of the derivative. So again, you're going to take out the x and plug in x plus h. So anytime you see an x, we're going to plug that in. So we already know what x plus h squared is. It's x squared plus 2xh plus h squared plus x plus h. So this is when you take out the x and you plug in x plus h. Remember, the second step is now you are going to subtract off the original function. So we go x squared plus 2xh plus h squared plus x plus h, and we're going to subtract off that whole thing, okay, which means this negative gets pushed through both. So we end up with a negative x squared and a negative x. So I'm just going to do this here instead of rewriting it. So I have a positive and a negative x squared. I have a positive and a negative x. So this equals, and again, you will always have values with an h in it every time. Step 2, you will only have values with an h. If I forget to push something through and I end up with, plus x or plus 2x or something, then I know I did something wrong. This answer will always have h's in every term. Okay, and then the next step is we're going to take that answer and divide off the h. So we take the answer, we divide off the h. The only way you can cancel is if you factor out an h first. Now, where does the 1 come from? So remember, you're dividing an h by every term. So with 2xh, I'm taking one of the h's out. I have 2x left. Here, h squared, I'm taking one of the h's left. I have h left. Here, I'm dividing h times h. Well, divided. H divided by h is 1. So if you need to see it this way, that equals 1. That's where the 1 came from. All right. Now, if you aren't sure, you can always double check by distributing that h back through, and it should take you back to your original. So h times 2x is 2xh. H times h is h squared, and h times 1 is h. So you should be able to go back and forth and see that. All right, so I can cancel my h's, and I get move up, and I get 2x plus h plus 1. So remember, your fourth step is you find the limit as h goes to 0 of the 2x plus h plus 1. Well, when h goes to 0, that cancels, so I end up with 2x plus 1. Okay, so that right there is my derivative. Okay, that's my derivative. So the slope of the tangent line at x equals 1 is 2 times 1 plus 1. Because remember, that's what this is your slope. Okay, it's the derivative. All right, so 2 times 1 is 2 plus 1 is 3. So the slope is 3. Okay, so that's how you find slope of a tangent line. You just find the derivative using definition of the derivative and then plugging in your x value. Okay, so the second part of this is now it's looking for the equation of the tangent line. Okay, so anytime it asks for an equation, you need 2 things. And this is equation of any line, doesn't matter. You need 2 things. You need a slope, which we have. We just found it right here. And you need a point. You need an x and a y. Well, we have an x. We know what x is. X is 1. So all we have to do is figure out what the y is. So to find y, you just do 1 squared plus 1. So 1 squared is 1 plus 1 is 2. So when x is 1, y is 2. Okay, so you need those 2 things. We have the slope, now we have a point, and now you're going to use the point slope format to find the equation of the line, which was y minus y1. Do you remember this from the review section? So if you don't, go back to the review section and go over getting equation of a line. So we have y minus our y1 is 2. The slope is 3. X minus our x1 is 1. And then we just clean it up. So y minus 2, we distribute 3 times x is 3x. 3 times -1 is -3. And then I'm going to add 2 to both sides. So the equation of the tangent line is y equals 3x minus 1. Okay, now let me show you on Desmos. So we have x squared plus x. Get rid of this one. Okay, so remember, we wanted to know what's the equation of the tangent line. Change my color. At x is 1. So here x is 1. Here is the point that's tangent at x is 1. We are looking for the equation of this tangent line. Okay, if you remember, our slope was 3. So the equation of the tangent line was 3x minus 1. Well, if I continue this down here, I would cross right there. You see it? There's my -1. So I go up 3 and over 1. Up 3 and over 1. There's my slope. And then it crosses. This is my y-intercept at -1. So it works. Okay. All right. So there is your equation of the tangent line. Okay. All right. So Now what we're going to do is we're going to use an application. Okay, we're going to do exactly what we just did using definition of the derivative in an application. Okay, so the population of a town, there's our population function. X represents the number of weeks. Always notice what your variables represent. So f of x is your y value. That's your population. X is the number of weeks. This right here is our domain. It shows that our number of weeks is between 0 weeks up to 20 weeks. This is saying determine the derivative. That's what that f prime of x means, using definition of a derivative. So you're going to get real comfortable with this f prime. You're going to see it over and over and over again. So just know that f prime just means derivative. So definition of the derivative is, we'll just write it here, so you don't have to go back. So sorry, my writing is so bad. Definition of a derivative is the limit as h goes to 0 of the difference quotient. That's your definition of the derivative. Okay, so instead of taking all 4 steps, I'm just going to kind of do it in one, as we go. So we know the first step, we take the x out and plug in x plus h. Okay, we know x plus h is x squared plus 2xh plus h squared. You're going to use that a lot, so you might as well memorize it. Okay, then we're going to keep distributing, keep simplifying as much as we can. So distribute that 3. Okay, now we're going to subtract off the original function, which means that negative gets pushed through, which changes the sign on all parts within the parenthesis. Now I'm going to cancel. And all I have left is 6xh plus 3h squared minus 12h divided by h. So now I'm going to factor the h out. And I can cancel. You can see how fast this goes. So the limit as h goes to 0 of 6x plus 3h minus 12 is 6x minus 12. That is your derivative. Okay, now B says determine the instantaneous rate of change, derivative, same thing, after 1 week. So all I have to do is use my derivative when x is 1. So 6 minus 12 is a negative 6. So here's what that means. So when we go back to the population after x weeks, so after 1 week, our population, remember instantaneous rate of change, how is it changing? Not what does it equal, but how is it changing? So our population is decreasing by 6 people after 1 week. Okay, so population decreases by 6. Just making sure it doesn't say like millions of people, thousands of people, anything like that. So population decreases by 6 people after 1 week. Okay, that's that instantaneous rate of change. We can look at what is our population doing? How is it changing at week 1? Well, now the next one says, all right, now what's the population change after 5 weeks? Well, we already have our derivative. So now we just plug 5 into our derivative. So 6 times 5 is 30. 30 minus 12, make sure, is 18, but it's a positive 18. So what this means is our population is increasing by 18 people after 5 weeks. Now, it's going to be super important that you can interpret. That's how you earn extra credit in this class on any test, is you have to interpret your answer. So that's why it's super important to know, well, what does the derivative mean? Derivative means how things are changing. If it's a negative slope, the change is negative, it means it's decreasing. If it's a positive slope, it means the change is increasing. Okay, so whenever you're finding derivative, you have to think, okay, how is it changing? What is the change? And it's at a very specific point. Okay, all right, so that's it for this one. I'm going to go ahead and stop there, and we'll keep going. Remember, difference quotient is only algebra. That's all it is just being able to do algebra. Okay, we'll stop there.